Alright, let's go over what we found in our soil composition experiment. So, we started by looking at the basic components of the soil, and according to National Geographic, soil is made up of both biotic and abiotic factors, like bacteria, organic matter, minerals, water, and air.
Right, and we know that soil typically consists of around 45% minerals, 5% organic matter, 20 to 30% water, and 20 to 30% air. But as we learned, these percentages can vary depending on the type of soil.
Exactly. So when we did the jar test, we found that our soil is sandy loam. It's got that loose texture, which means that it drains well, but it still has enough nutrients for plants. That makes it a good base for a lot of crops.
Yeah, sandy loam is ideal for plant growth, but we also need to dig into the chemical tests we did. Our results show a few important nutrient deficiencies. For example, potassium levels were dangerously low. The soil has a KO depletion, which means it's lacking a key of nutrients that help plants stay healthy and resist stress.
Right, and then there's nitrogen. Our soil had NO depletion, which is a big deal because nitrogen is crucial for plant growth, especially for producing healthy leaves and stems. Without it, the plants can struggle to develop.
And phosphorus. Our soil had a P1 deficiency. Phosphorus is really important for root development and energy transfer in plants, so that could impact how well plants establish themselves.
The pH level was another factor. Our soil came out as 7.5, which is slightly alkaline. This might affect how easily plants can absorb nutrients, especially those that thrive in more acidic conditions.
So, while our sandy loam is good for planting, these nutrient deficiencies are a serious concern. We'll need to add fertilizers to boost the potassium, nitrogen, and phosphorus levels, and we might also have to consider soil amendments to lower a pH to a bit of a better nutrient availability.
Absolutely. It's a great example of how soil composition and chemical properties can work together to support plant growth. And now we know what exactly to adjust to make sure that there are healthy crops in the soil.
Exactly. It's about understanding the soil profile, its layers, its textures, and the nutrients it contains. That way, we can make the right decisions for healthier, more productive plants.
Definitely. This experiment really shows how science and hands-on learning can help us solve real-world problems.